My name is Florina Muntanescu. I'm a developer advocate at Google. And today I want to tell you about a few solutions that we developed. Solutions for problems that I think all of us as developers have been trying to solve again and again. Chances are in every project that we've been working in. So let's say that we want to perform actions in response to changes in lifecycle status of an Android component. We want to be able to persist UI data across configuration changes. And we want to observe certain values being changed. All of these problems are stuff that I think we all faced. And with the architecture components, and more precisely with the lifecycle, live data, and view model, these are the problems that we try to solve. So today I'm going to go, and show how all of these work and how you can use them, and how you can also create some custom components that hopefully will help you with your own custom problems. So let's start with the lifecycle. So the lifecycle represents the lifecycle of an Android object. So for a lifecycle, we have events and we have states. So we can see these events and the states as, so the states would be the nodes in the graph, and then the events would be the path from one node to another. I won't go now into details in all of this, because I'll go a bit more in depth in a few slides, I promise. So apart from the lifecycle, we created the concept of a lifecycle owner, so the object that has a lifecycle. The lifecycle can be retrieved with the getLifecycle method. So the objects that have a lifecycle are app-compat activity, or also actually the implementation is done in the fragment activity, but also the fragment, the process lifecycle owner, and the lifecycle service. So let's go a bit more in depth, and I'll start with the app-compat activity and with the fragment, because in the end, these work pretty much the same. So let's go over a few scenarios and see how these events are triggered based on what, and how they change the state of the lifecycle. So let's take a case when the activity is started and then finished. So when the app is started, then for that activity, the activity is in initialized state. Then once the onCreate method is called, afterwards, the onCreate event is triggered, and then that event changes the state of that activity to create it. After the onStart method is triggered, then the event is, the lifecycle goes in the onStart, or triggers the onStart event, and then the state is started. Afterwards, the onResume method is called, the onResume event is triggered, and then the state of the activity is resumed. Now, let's take the case when back is pressed to finish the activity. Here things go a little bit different, because before the onPause method is called, the onPause event is triggered, changing the lifecycle state to started. Then, before the onStop event is triggered, and then the created state is, the lifecycle is moved to the created state. And then before onDestroy, we have the onDestroy event, and then the activity or the fragment being moved to the destroyed state. So overall, these are the main states, and this is how they look. So we start from initialized, and then we go to created, started, resumed, started again, created, and then destroyed. Let's go in another case. Let's say that we're rotating the device, so we can trigger a configuration change. So the first part is the same. I won't go over that again. But let's see what happens once the device is rotated. So once the device is rotated, onPause is triggered. So things are a bit different here when we have onSaved instance state, because when the lifecycle belongs to an app-compat activity or fragment, the lifecycle state changed to created, and onStop event is dispatched when the onSaved instance state is called. So these are a bit different than the other ones, because first the created state is triggered, and only afterwards, based on the state, the onStop event is called. And then afterwards, the onStop method is called. That triggers the onDestroy, and then the move to the destroy state, and then onDestroy. But what's important to remember is that once the UI is in onSaved instance state, then from there on, we have an immutable UI. So if we're trying to modify the UI state afterwards, well, that's when you're going to get all the crashes that I think we all know. Because the fragment transition state is already saved. So how would you handle this? What's the better way to work with this? Well, you would use the lifecycle is@list and then the started state. So then you know that when the UI is in a started state, from there on you can actually work with it, and you know that you won't have any issues with the state of the UI. So I talked about a little bit. I said that this applies for both fragment and activity, but things are a bit different because actually fragments have two life cycles. The life cycle of the fragment itself, so the one that's it's returned by get lifecycle, but also the life cycle of the fragment's view. So in the cases of attached or detached fragments, these two life cycles differ quite a lot. So more precisely, the fragment view lifecycle can happen multiple times for a single fragment lifecycle. So right now, we didn't expose anything for the view's lifecycle owner, but we are working on this because of all of these cases. So hopefully, we'll have something for you soon in the support library. The class that provides lifecycle for the whole application process is the process lifecycle owner. So what's going on here? So under the hood, the process lifecycle owner works with a content provider. So it automatically knows when the process was started. So then we trigger directly on create event, which moves the state of the process to create it. So if you notice here, we're missing the initialized state. And this is because, well, the process just starts. But then once the first activity is created, the first methods that will be, or the first events that will be triggered correspond to the onStart and onResume of that activity. So for example, when the onStart method is called, it will trigger the process onStart event, moving the process to started state. And then when onResume is triggered, then the onResume event for the process is called, moving the state of the process to resumed. But then afterwards, as other activities are added, nothing happens, because nothing else really happens with our process. But when the application is sent to background, then onPause and onStop are triggered for those activities. So correspondingly, our process lifecycle will trigger the onPause event with the started, moving the process in the started state, and then the onStop will trigger the onStop event, moving the process in the created state. So what's important to note is that even if you have several activities, all of these will be triggered only once for the process. Even more, the onPause or onStop configuration changes are ignored. So you will only really get this once when the app is sent to background. But then once you get to the app to foreground, then onStart and onResume methods from the corresponding activities will trigger the onStart event for the process, moving the process in the started state, and then the onResume will trigger the onResume event, moving the process into resume state. But then as activities get closed, once we got to the last activity, and we're also closing that one, so we're closing the application, those two will also trigger, again, the same events for the process. So what's important here to note is that we've added a delay in the onPause and onStop triggering. More precisely, it's a 700 milliseconds delay. So this is enough to guarantee that the process lifecycle owner won't send any events if activities are destroyed or recreated due to a configuration change. So in the end, this is the workaround that allows us to ensure that we're only getting these when the application goes to background and foreground. So overall, this is how our process lifecycle looks like. So if you need to implement things like analytics to know when your app was in foreground and when it went to background, these would be the lifecycle events that you would need. If you don't need specific, like super precise milliseconds thing, I think this is quite safe to be used. And then the last lifecycle owner that we provided is the lifecycle service. So more precisely, this is a service that is also a lifecycle owner. So here we're only using a few events. So when the service is on create state, then the on create event will be triggered for the service, moving the service in the created state. When the onBind is called, or onStart for the service, then the onStart event is triggered for both of these, and then the service is in the started state. But then once the service is destroyed, both the onStop and on-destroy events are being triggered, and then the service is moved to the destroyed state. So to implement such an observer, you would implement your own custom class, implementing the lifecycle observer interface. And you would define the methods that should be triggered whenever specific lifecycle events are triggered. So for example, you would, let's say, start listening for location changes in a method annotated with @lifecycle event on resume, and maybe stop listening in on pause. So here, everything works based on annotation processing. But if you're using Java 8 in your app, then chances are you should use the default lifecycle observer. So here, like this, you're skipping over this annotation processing phase, and you can just implement the methods that you need. So how do you combine everything? You would get the lifecycle from your activity, from the fragment, from the process observer, from the service, and you would just add the observer. And then you would let the support library and the framework do everything for you. What happens with the lifecycle of a view? Why don't we have something for this? Well, as I was saying, for the lifecycle of the fragments view, things are not as easy for views in general. So we do have this in mind, but we haven't provided anything for this yet. How about custom lifecycles? Someone was asking me the other day, what if I want to implement a lifecycle for my library? Can I do that? And the answer is yes. I would see this as a more expert level use case, but I would say that you can implement this also for your own custom objects. So you can implement your own lifecycle owners. You would still work on the same objects, on the same events and states that we provide. But as you've seen also in the case of the process lifecycle owner, there we skip the initialize and also on destroy events. So if this would work for you, then you're free to implement these. Okay, let's see what's going on with live data. So live data is actually just a data holder. So other objects can set values to that live data, and then that live data can be observed in the context of a life cycle. So more precisely in the context of an activity or fragment life cycle. And then based on this, you can update the UI based on the data in the live data. But when the activity is on pause or on destroy, so for example, because of a configuration change, that subscriber is removed and the live data is considered as inactive. So this means that even if you're setting values to it, nothing will happen. The values won't be propagated. But then once you rotate the device and then the application is again recreated, the activity is again recreated, then the values are again propagated because live data is in the active state. So the class that would help you set these values to the live data is the mutable live data. You would use the post value method to set the values on a background thread and set value when you're setting the values from a main thread. So especially I think if you're using Kotlin, one thing that I don't like is to expose this mutable object to the outside of the class. So what I prefer to do is to expose a live data object and use a backing field that is a mutable live data. So like this, I ensure that only the class that I'm working in, can change that live data. So I'm still keeping this immutability principle. So to actually observe and react on the changes in live data, we would observe it, and then whenever the onChange method is triggered, we would update the UI. So under the hood, live data just allows a list of observers, and whenever a new value is set there, it just triggers or notifies all of those observers of the change. Okay, let's go into more complex cases. Let's see if we can transform the live data. So let's say that whenever we have a network error or when a user was deleted or when a user is updated, we want to show a toast or a notification. So in order to do this, it means that our live data has multiple sources of data. So whenever any of these has triggered, we know that we need to show that message. So this means that we would have a live data for network errors, a live data to tell us that the user was updated, to tell us that the user was removed, and so on. So we would create a display message based on a mediator live data. The mediator live data allows us adding multiple sources and allows us to define whenever one of these sources was changed. So whenever the value from one of these sources was changed. So more precisely, we know that whenever the user was updated, we want to show a message that says user with a specific username was added or updated. And then whenever we have network errors, we want to show whatever that network error was. OK, let's complicate our case. Let's say that we have a search field, and we can look for users based on a name. And then from somewhere, from a repository, let's say, we would get a list of users, and we only want to display the names of those users. So search for a user, get a list of users with that name. So this means that we only need to subscribe to a live data of a list of strings. So to do this, we would get the data from a repository. So whenever something is searched, we would get user with a name. Then the repository would create a new instance of a live data. But the live data would be a live data of a list of user, because that's what the repository has. And then we would need actually to do some transformation to give us just the name of the user. And then, based on that, to display the data. So to do this transformation between the list of users to the list of strings, we would use the transformations.map. So here, we would get as input the live data of a list of users. And then we would apply a function to it, in our case, to just transform a list of users to a list of strings. And then the result, this username result, is actually a live data of a list of strings. So exactly what we need. But here's the thing. Let's say that we're looking for the user with the name Alice. The repository is creating a new instance of that live data for us. We're transforming it, we get the list of strings. And we display the list of users. But then, we're looking for the user with the name Bob. There, the repository again creates a new instance of a live data, and our UI is subscribed to that. So in this moment, our UI is subscribed to 2 instances of live data, because we never removed the previous one. So this means that whenever something changes, let's say in the repository, and our live data of Alice triggers again, we can end up with, well, with a UI that doesn't really show what our user needs to see. So what we actually need is a mechanism that allows us to stop observing from the previous source whenever we want to observe a new one. So something like this. So in order to do this, we would use a switch map. So more precisely, under the hood, the switch map just uses a mediator live data that removes the initial source whenever a new source is added. So it does all of this mechanism of removing the observer and adding a new one for us. OK, let's see a bit the bigger picture for this screen. So I said that we would have a repository that returns a live data of a list of users. And then in our user view model, we would actually have a mutable live data for all the queries that we're doing. So every time we're searching for a new user, we would just put a new value in that mutable live data. And then we would compute the result by triggering every time we get a new query, a new user search, we would trigger a search in the repository. So like this, automatically, the previous search is removed, and then the search for the new user is added. OK, how about custom transformations? Well, as I was saying, in the end, everything is based on mediator or mutable live data, so based on the stuff that we already know. So we can build our own custom transformations. So for one of the projects I was working on, I needed a way to get distinct values. So if you're using RxJava, I needed something very similar to distinct until changed. I wanted my live data to only emit distinct elements whenever something was being put in it. OK, so what did I do to fix this or to implement this? So I used the mediator live data. I added my source. And then in that source implementation, I kept the last value that was added. And then whenever onChange was triggered, I was seeing whether the new object is the same or not with the previous object. And that's all. So you can also do these kind of similar transformations. another question that I was asked quite a lot is whether live data is replacing RxJava. Well, the thing is that live data is quite different from RxJava. Live data is just a data holder. It doesn't have all the fancy operators that RxJava has. It doesn't have any terminal events. And more precisely, it works with the lifecycle. It works in the context of a lifecycle. So what I'm suggesting more is have live data and RxJava working together. So to do this, we added a new artifact. We added the live data reactive stream that allows you to have this conversion between live data and RxJava. So more precisely, you can create a live data from a publisher. So in this case, whenever the live data is being observed in the context of a lifecycle owner, whenever data is being put in the publisher, then the live data will emit. We'll set that value. But then, when that lifecycle owner is removed, then also the live data becomes inactive and is not observed anymore. So then, even if that publisher gets new values, those values won't be set in the live data. So this means that at the time when you're subscribing again to the live data, you might end up with things that are not really up to date. So be careful there. Also, we're not really handling on error because this is something that we believe that you should handle either on the Rx state, so before passing the value to live data, or that you should encapsulate your state in like maybe a result object where you have an on success and an on error case. So it's up to you. But I think this also shows that difference between RxJava and live data, the fact that they don't handle errors. Okay, let's say that we're going the other way around. Let's say that we want to create a publisher based on a live data. So here, whenever we're calling publisher.subscribe, then we start observing the live data. So here, when we're creating to publisher, we're also putting the life cycle so we know who's the owner, the lifecycle owner of that live data. So we're observing that data, and whenever data is set to the live data, we're pushing it to the publisher. Okay, but then once we call cancel, then that's it. We stop observing that, that live data, and then we stop putting data in the publisher. Okay, let's go to our third component for today, the view model. So I was showing this kind of a, let's say, architecture-ish before. So I was saying that we have the UI, we have the repository, and we have these connections, this getting the user with a name, this working with the data, so preparing the data for the UI to be displayed. Well, the class that we created to do this, to handle the UI data, is the view model. So the view model would observe the user's actions, and then would expose data for the UI. So it would expose it via live data. So the Android, the view models in the architecture components are exposed either as a view model, so an abstract class that you would implement, or you would use an Android view model. So the difference between these is that the Android view model takes the application as a parameter. So the view model under the hood, in the end, is just saved in a retained fragment. So this means that the life of the view model is something like this. It would be created when the activity is created, or the fragment. You can replace this also with a fragment. And then whenever the activity is destroyed, only then the onClear method of the view model is triggered. So as a consequence, because under the hood everything is just a retained fragment, the view model survives configuration changes, but it will not survive just pressing back in your application or killing the application from recent, or when the fragment kills the app. So in general, closing the app also means that you're completely closing or destroying the view model. Another comparison that I heard a lot is between the architecture or the guide to app architecture that we suggested and the MVVM pattern. So while I think there are some similarities, I don't think they're really the same. I think both of these promote the same separation of concerns. So, for example, we have a repository that would work with the network and with the persistence layer. We would have a view model that's a holder for the data that exposes data for the UI but does not have a reference to the UI, just to make sure we're preventing memory leaks. And then the UI, whose role is just to display the data. So this separation of concerns is definitely something common for both of these suggested architectures. Also, we have the idea of driving the UI from a model. So in this case would be the repository being the single source of truth. And whenever that is updated, the UI would also automatically be updated. Then what we're adding extra to our guide to app architecture is also a bit of let's say, guidance on how you should save data. So for example, on saved instance state, you should make sure that you're saving the minimum amount of data that you need to recreate your UI. So for example, it can be your user IDs, or in general, I would say the smallest thing that you need, so you can afterwards just request the data that you need from the database. Then in the view model, you would save the data for the UI, so the data that would need to survive configuration changes. But then the data that you really need to persist, you would save it in the database. But then in terms of differences, well, the thing is that you don't have one MVVM implementation. You don't have one MVVM definition. If you look just on GitHub on MVVM repositories, chances are every repository would have its own implementation. In the end, MVVM started from .NET, and we don't really have a precise guideline of how this should be applied in Android. We don't really know how the view model should be persisted, how it should live. Should it be destroyed and recreated in onResume and onPause? Should it survive like our view model? Is surviving or not? So I think this is also the difference, the fact that we don't really have a standard for MVVM in Android. So in the end, both of these, both the guide to app architecture and also the MVVM pattern, are advocating for the same principles, are advocating for scalable, for modular, for testable applications. And this is what we've been trying to do with the help of the lifecycle, of live data, and the view model. And not only these, but also with the help of Room and paging, which I'll be talking about tomorrow, and then another shameless plug, we'll also be having an architecture components workshop. So thank you for listening to me today, and I'll hope to see you at my talks tomorrow.